This is Mission Control Houston. Good afternoon. Today is April 17th, 2019. You're looking at a live view of the Northrop Grumman Cygnus vehicle on top of an Antares rocket out at the Wallops Flight Facility, ready to launch here in just about a half an hour. Cygnus is poised on top of the Antares 230 rocket out at the Virginia Mid-Atlantic Regional Spaceport Pad 0A at Wallops Flight Facility in Virginia. We're here in Mission Control Houston monitoring the International Space Station, the ultimate destination of the Cygnus vehicle launching on top of the Antares rocket here today. This is a live view of the International Space Station Flight Control Room. Flight director here in the room is Brian Smith for the Orbit 2 team. Next to him is Andreas Mogensen, the Capcom, who has been communicating with the crew aboard the International Space Station throughout the middle of today. Here in the room, we'll have some visiting vehicle officers. You can see on the right, Dory Tomiko, next to Jessica Doy. The duo will be working with flight controllers, the Northrop Grumman flight controllers over in Dulles, Virginia. This is a view out of the Wallops Launch Control Center next to the launch pad at Wallops Flight Facility. Controllers here are watching over today's launch scheduled for just under 30 minutes. Over at the Northrop Grumman Mission Control Center, Mission Director Ken Peake is leading the teams there. The teams you are seeing in this room will be leading the Cygnus throughout its flight from launching here in just under a half an hour through its journey to the International Space Station over the course of a day and a half. Everything is looking good so far for a launch on time at 3:46 p.m. Central Time, just under 29 minutes from now. At the time of launch, the International Space Station is scheduled to be over the Atlantic Ocean, just northeast of the Lesser Antilles. We're looking at a 4-minute, 59-second launch window from the time of launch, the exact time of launch being 3:46 and 7 seconds p.m. Central Time. The weather today is at 100% favorability, looking at about 54 degrees Fahrenheit at the time, just over 12 degrees centigrade. Again, 100% favorability, clear skies for the launch coming up here in just about 28 minutes. Again, the ultimate destination of the Cygnus cargo craft over the course of its day-and-a-half journey to the International Space Station. Welcoming the vehicle will be the crew of Expedition 59. On board the International Space Station is, from left to right, David St. Jacques of the Canadian Space Agency, Anne McClain of NASA, Oleg Kononenko, the commander of Expedition 59 of Roscosmos cosmonaut Alexei Ovchinin. To his right are NASA astronauts Nick Hague and Christina Cook. Anne McClain will be the one capturing the Cygnus vehicle in just about a day and a half as the prime robotics operator. She'll be backed up by David St. Jacques of the Canadian Space Agency, Nick Hague standing by to monitor telemetry during the approach of the Cygnus vehicle to the International Space Station. On top of the Antares rocket, you can see the fairing. Underneath the fairing is the Cygnus cargo vehicle, loaded with about 7,600 pounds of cargo. To date, that is the largest load that was flown, a Cygnus vehicle to be flown on an Antares rocket. You can see the breakdown here. Just about half of that are scientific investigations, many of which will be loaded onto the International Space Station, some of which were part of a late load procedure, which we'll go over during today's broadcast. Back at the pad, you can see a bit of ducting. This is conditioned air that's being fed to the payload bay and to the first stage at the bottom of the vehicle. Plenty of food and supplies and scientific experiments aboard the Cygnus vehicle. Some of the food include many items like smoked turkey, pork chops, shrimp cocktail, mashed potatoes, candied yams. The list goes on. Again, some of the conditioned air billowing from the Antares vehicle. This air is being fed to the payload bay at the top where the Cygnus vehicle is housed, and of course the first stage at the bottom. There's going to be a series of milestones. First, the go, no, go conducted here in Mission Control Houston. At this time, the Antares has already been loaded, the 2 liquid fuel engines with liquid oxygen and R21 kerosene. At the T-minus 30 mark began the final checks of the flight termination systems, already underway. At 22 seconds before launch, you will see the transporter erector launcher will retract from the vehicle. That's that sort of scaffolding you're seeing in this view of the launch vehicle out at Pad 0A at the Mid-Atlantic Regional Spaceport. After this tower pulls back, it'll be another 10 minutes until a go, no, go poll is conducted from Mission Control Center at Dulles. The Northrop Grumman flight controllers will conduct a go, no, go for the final steps to commence launch. Again, that launch 3:46 p.m. Central Time today. At T-minus 5, the vehicle will switch to internal power before 3 minutes and 30 seconds before launch, which will initiate auto-sequence handoff for terminal countdown. Essentially, this will mark the time where the computers take over for the final steps up through the launch at T-minus 0. At about T-minus 40, as part of this automatic sequence, the takes will be pressurized until, and this is the one of the major final steps until T-minus 0 liftoff. Again, 3:46 p.m. and 7 seconds p.m. Central Time today. After liftoff, that first stage will burn for 3 minutes 35 seconds until main engine cutoff. You'll hear performance calls from Northrop Grumman flight controllers marking the status of the vehicle and the rocket throughout its journey. After main engine cutoff, we'll await stage 1 separation. The second stage and the rest of the vehicle will coast for a bit before the fairing separation occurs to reveal the Cygnus underneath, and the inner stage at the back of this configuration of the vehicle will separate, the inner stage being an adapter that connects the first and second stages. After this short coasting period will be stage 2 ignition. This second stage burns for 2 minutes and 30 seconds and is a solid rocket motor, meaning the whole thing will burn. During the 2 minutes and 30 seconds, the vehicle will climb about 40 miles before the engine is exhausted over that 2 minutes and 30 second burn. After the second stage burnout, the vehicle will coast for 2 minutes before the Cygnus separation occurs just after the 9-minute mark into flight, and the vehicle is inserted into orbit. We'll stand by for just over 2 hours, where there'll be a series of burns before the solar arrays are deployed. We'll be back on for that coverage at 6 p.m. Central Time. Solar array deploy occurs over just about half an hour. After that, there's a series of milestones, including some burrs over the next day and a half until the ultimate rendezvous of the Cygnus cargo vehicle on its CRS-11 mission to the International Space Station on Friday, April 19th, for a capture scheduled at 4:30 Central Time. It's a busy time in spaceflight. This mission will be followed shortly, just over a week from Friday, or just about a week from Friday, of the SpaceX Dragon on a CRS-17 mission. That's April 26th, and it'll stay in orbit for 1 month. The Cygnus will conclude its mission to the International Space Station in July, separating with thousands of pounds of trash from the station, and then begin a solo long-duration mission in space. At this time, the transporter erector, this is that scaffolding you see to the left, the vehicle has been armed. We should shortly see that transporter erector start to back away just here in a few minutes. At T-minus 22, the arming transporter erector has been armed. It'll take some time before it retracts, actually shortly before the time of launch. Every Cygnus vehicle is named after a major contributor in the world of spaceflight. All of the folks that it's named after have passed. This vehicle, the Northrop Grumman, on its commercial resupply mission 11, is named the SS Roger Chaffee. Roger Chaffee was born February 15, 1935 in Grand Rapids, Michigan. He got his private pilot's license through the Naval Reserve Officers Training Corps before graduating from Purdue in 1957 with a bachelor's in aeronautical engineering. After graduation, he flew for the Navy and accumulated over 1,800 flight hours before his selection as an astronaut for the Apollo program in 1963. He began his training as an astronaut in 1964, and during his time of training served as a CABCOM in mission control during the Gemini program. He received an assignment to fly on the first flight of Apollo in January 1966. On January 27, 1967, Chaffee, along with Virgil, Gus Grissom, and Ed White, perished in a fire that ignited during a plugs-out test of the Apollo command module out of the Kennedy Space Center. Chaffee's sacrifice began redesigns of the Apollo vehicles that ultimately landed Neil Armstrong and Buzz Aldrin on the moon nearly 50 years ago on July 20, 1969. The Apollo program being 50 years ago. Just about a month from now, in the middle of May, will be the 50th anniversary of the launch of the Apollo 10 mission. And of course, the landing of Neil Armstrong and Buzz Aldrin on the moon will, this year, in 2019, will be the 50th anniversary of the landing on the moon. Everything's still on track for an on-time launch at 3:46 p.m. Central Time today, just about 17 minutes away from that time. Everything looking good. Dulles Flight Controllers tracking the vehicle and reporting good milestones as we count down to that final time of liftoff. Joining me in Mission Control today is Robin Hurd, the Deputy Program Manager for Launch Vehicles out at Northrop Grumman. Robin, thank you so much for being here.
Thanks for having me today. I'm really excited to be here.
I'm curious to hear more about the Antares vehicle. Now this is the Antares 230 vehicle. There's a little bit of modifications that happen for this late load capability. Tell us about the vehicle. What is the vehicle that's actually launching Cygnus today?
Absolutely. So NG-11 is the mission that will fulfill our contract to NASA under the CRS-1, or the first phase of our commercial resupply services contract with NASA. So our next mission will be CRS-2, and for that we'll be flying a vehicle configuration that we call 230 plus, but what we have here today is a little bit of a hybrid. It's a bit of an upgrade from the 230, just so that we can provide a little more performance. And one of the things that it has available to it is what we call a pop-top fairing. So it allows us to perform a load of cargo later in the flow than we normally would, and actually is able to be performed at the launch pad now.
So tell me about the construction of Antares. About the time do you actually get the call to design an Antares, know when the launch is, and begin the process to start getting ready for an on-time launch?
Sure. So, if you want to go all the way back to the component level, the process of building an Antares actually starts years before we launch. But in terms of integration, a flow would take typically 6 to 9 months from the time that we gather up all of the different assemblies and bring them into our horizontal integration facility at Wallops Island and start pulling them together into something that you could actually identify as a rocket.
Now, you said this was a little bit of a different configuration. Tell me about the late load process. What was different about this particular launch?
Sure. So one of the unique features of this launch is the cargo late load. So we have built some new electrical and mechanical ground support equipment that allows us to actually take the vehicle from the configuration you see here, where it's vertical at the pad. It can actually convert down back into the horizontal position. We're able to drive what we call a mobile clean room right up to the tip of the fairing so that we can load time-sensitive research and other perishable items that NASA needs to provide within 24 hours of launch.
And that's a pretty tight turnaround, but there's a critical science that's actually being loaded into Cygnus to accommodate this. One of them is the Rodent Research 12 mission. That'll be arriving at the station, and then, of course, be one of the first, actually, experiments to come out of Cygnus once it arrives. Now, we have some photos of rollout here. Tell me about the rollout process. Once it's ready to go, what does that look like?
Yeah, so that looks like just a beautiful evening at the eastern shore there for rollout. So you can see that we have some tarps over the top of the fairing there. That just helps keep everything environmentally protected. We've got the transporter erector launcher there that's being used to roll the vehicle from about a mile from our horizontal integration facility out to the pad. That's a slow process. It goes probably about a mile per hour. It's a pretty slow walk for the folks that accompany it out to the pad. And there's another beautiful shot with the big NASA meatball on the water tower there.
Now, of course, here it is, a live view, again, billing some of that conditioned air. We're now tracking just about 13 minutes from launch. Everything looking good. As you can tell, this is an afternoon launch, a beautiful day, clear skies, just about 54 degrees Fahrenheit, and everything's on track, and we've been counting down these milestones to an on-time launch so far. Now, one of the next milestones that we're looking forward to is a go, no-go poll from Northrop Grumman flight controllers over at Dulles. What are they looking for? What are the things that they're checking from the operations side?
So they're going to be polling folks like our Antares chief engineer, all of the safety officers, and some of the key engineering leads. And those folks are going to be looking at their telemetry data, making sure that the health and the status of the vehicle is all within constraints and that we are ready to go into the final stages of launch today.
Now, of course, after launch, it'll lift off and rendezvous with the station in just over a day and a half. It'll remain there for 3 months until it separates and begins an extended stay. Part of that is some secondary missions, including the deployment of some ThinSats. What are these ThinSats that the Cygnus is going to be deploying?
So I'm glad you asked. The ThinSats are a really cool project. They're a secondary payload on Antares. They'll deploy after Cygnus has been deployed into the orbit. The ThinSats are they're student-led satellites. So they were created by students in 9 different states, actually, and they're going to allow kids to see things like a GPS position, temperature, and just get real telemetry data from space, which is really neat.
And that's an exciting time. Of course, it has the mission to the International Space Station to conduct first, and we'll expect that here on time in just under 12 minutes. At this time, Northrop Grumman has already conducted their go, no-go poll, and from the Northrop Grumman side, we are go. Now, again, part of these milestones is from the go, no-go poll. And just about 5 minutes before launch, the vehicle will switch to internal power, and then we'll begin the initiate auto sequence handout for terminal countdown.
And Ops 2, this is LC on countdown 1, step 394. Your go to start engine evacuation.
LC Ops 2, evac started.
Now what you're hearing is some of the calls from Northrop Grumman flight controllers tracking some of the milestones before we get to that final launch at 3:46 p.m. Central Time today. Some exciting scientific investigations going to the International Space Station here in just about 10 minutes away from launch. Everything tracking from the Northrop Grumman side to be an on-time launch today. One of the investigations going up is a robot called Astro B. This is NASA's next generation of free-flying robots aboard the station. They're self-contained, cube-shaped robots and are designed to help scientists and engineers develop and test technologies for use in microgravity to assist astronauts with routine chores and give ground controllers additional eyes and ears on the space station. Now, these robots, powered by fans and vision-based navigation, perform crew monitoring, sampling, logistics management, and accommodate up to 3 investigations. They can be operated automatically or from the ground. Another investigation are manufacturing fiber optic cables in microgravity. This is called space fibers. This investigation will evaluate a method for producing fiber optic cable from a blend of zirconium, barium, lithium, sodium, and aluminum. This is called Z-blan in space. Z-blan produces glass 100 times more transparent than silica-based glass, exceptional for fiber optics. Microgravity suppresses 2 mechanisms that commonly degrade fiber, and previous studies showed improved properties in fiber drawn in microgravity compared to that fabricated on the ground. The Z-blan fiber is a unique candidate for improved imaging, remote sensing, and next-generation optical communications on Earth due to its low loss and higher bandwidth.
Enabled, voltage nominal, and commands are clear. Copy. Elect 1, check 397 and 398.
The bioanalyzer is another experiment from the Canadian Space Agency. This is an instrument that serves as a platform for scientific experiments where astronauts can easily test different body fluids such as blood, saliva, and urine and get returned key biomedical analyses within a few hours. Scientists will be able to use the bioanalyzer's data to accelerate science experiments. In the future, this type of device could help to keep a closer eye on astronauts' health. Another experiment is this image of David St. Jacques, and astronauts show accelerated arterial stiffening during their time in space. These are thicker artery walls and signs associated with the development of insulin resistance after spending 6 months in space. And these dramatic changes in the carotid artery, aging was unrecognized until recently. So the vascular aging investigation, this investigation you're seeing here, will include critical onboard investigations to test the relationship among a crew member's metabolism, aging arteries, and aging bones. The results of this study could have great importance for assessing a newly identified risk for astronaut cardiovascular health, potentially pointing to mechanisms to reduce risk. And these are, again, just a few of the more than 3,400 pounds of science currently loaded on board Northrop Grumman's CRS-11 Cygnus vehicle, now under 7 minutes from launch.
VZX is closed and OCCS is in automatic control mode.
And I copy Prop 1.
LC, VTSO activation verified.
Roger that. Check 402. Ops 2, 403. Initialize ground ordnance power supplies.
LC, Ops 2, ground ordnance power supplies initialized.
LC, Elect 1, ground ordnance power supplies nominal.
Copy. Elect 1.
LC Site Control, FA ECS transfer to GN2 is confirmed.
Copy that. Site Control. We'll check 405 complete.
So Gary, you can see right now that the top half of the first stage is really very cold with that cryogenic liquid oxygen. The Antares logo that you would normally see running down the side there is completely obscured by ice, and we've got the sort of evaporative process happening on the liquid oxygen boiling off of its relief valves and vent valves there.
Coming up on T-minus 5 minutes. And Ops 2, your go for step 406, initiate engine priming.
Priming started.
Ops 1, you go to transfer avionics to internal power.
LC Ops 1, avionics internal power on, standby 5.
You hear those calls, the vehicle will switch to internal power. Before about 3 minutes 30 seconds prior to launch, we'll initiate auto sequence handoff for terminal countdown.
Open FTS umbiloop and verify green indication.
LC Ops 1, FTS umbiloop open and green.
Copy that, Ops 1.
LC Elect 2, FTLU, and FTS receiver indications are nominal.
Copy Elect 2, we'll check 410. Ops 1, step 411, you go to send all arm command.
LC Ops 1, all arm commands sent.
LC Elect 1, SNAs, ODMs, all armed.
Copy Elect 1. NASA TD, report range status. Range is green. Copy, range is green.
LC MES1, priming verified, MES1.
Copy, priming verified, check 414. And launch team phase 3 dynamic limits will be active at T-minus 3 minutes.
FC commanded to flight mode.
Three minutes before launch, we're now in the terminal
Auto
count
sequence
until
startup.
launch on time,
Copy, auto
3:46 p.m. Central Time.
ODM bus voltages and currents are nominal.
Roger, Elect 1. Nav, step 420, verify ready for nav mode.
LC nav, or nav ready for nav mode.
Ops 2, step 421, switch to nav.
Orb nav to navigate.
LC nav, or nav telemetry verified.
Copy that, nav. We'll check 422 complete. And T-minus 2 minutes on my mark. Mark.
Now under 2 minutes for launch, everything's still looking good during this automatic countdown.
T-minus 30, T-minus 1 minute, 30 seconds on my mark. Mark. And T-minus 1 minute on my mark. Mark.
Now under a minute to launch, and just about 10 seconds then takes will be pressurized. Everything's still on track for a liftoff on time.
T-minus 30 seconds. T-minus 10. 5, 4, 3, 2, 1. And we have engine ignition.
And we have liftoff of the Antares NG-11 mission to the ISS. Engines at full power. Attitude is nominal. Core pressurization looks good. Power systems look good. Stable operation, full power, both engines. Core pressures look solid. Attitude is nominal. TVC is nominal. Power systems look good. Engines remain at full thrust, operating nominally.
Everything looking good during this first stage burn. It burns for 3 minutes, 35 seconds.
Throttling back to 55% power. Attitude remains nominal. Nominal operation at 55% power. Throttling back up to full power. Engines are back to full power. TPC remains nominal. Attitude nominal, just T plus 60 seconds. Altitude passes 25,000 feet. Pass through transonic. Attitude is nominal. Engines continue to operate at full power.
Everything looking good. About 10 more seconds of this first stage burn.
With nominal attitude. Pass through 40,000 feet altitude. Engines remain nominal at full power. Fuel pressurization is nominal. VNG3 is on. Altitude past 60,000 feet. Engines remain nominal. Attitude and power systems all look good. Coming up on T plus 2 minutes. Engines continue to operate nominally at 100% power. TVC steering, power systems.
2 minutes into the flight, 1 minute 30 seconds until this main engine cut off.
Passing through 100,000 feet. Power systems remain nominal. Attitude is good. Engines continue to operate at full power. Engines remain nominal. Power systems are good. Attitude is nominal. Core pressures look nominal. Approximately 1 minute till main engine cutoff. Engine power is nominal. Attitude is nominal. Avionics power is good. We're starting our slow throttle ramp for G limiting. 200,000 feet altitude as we approach T plus 3 minutes. Attitude remains nominal. 10,000 feet per second. Engines have throttled back to 55.
About 30 more seconds of this burn. Main engine will cut off. Stage 1 will separate, and the vehicle will coast for just a bit before fairing separation.
Engine operation at 55% power is nominal. TVC slew for main engine cutoff has started. Attitude remains nominal. Engine operation continues to be nominal. Altitude 300,000 feet. And we have main engine cutoff. Attitude remains nominal post-shutdown. Stage 1 separation. ACS performance is nominal. Stage 2 ignition will be in approximately 30 seconds.
Again, this is a coast period.
Antares is now coasting in preparation for Stage 2 ignition. Stage 1 delta V was 17,348 feet per second. Altitude is 130 kilometers. Interstage SEP. Attitude remains nominal. TVC batteries initiated. And we have Stage 2 ignition. Attitude remains nominal. The Castor 30 XL motor will burn for approximately 2.5 minutes. Attitude is nominal. Motor pressure is nominal at approximately 100 psi. Power systems look good. Stage 2 TVC is nominal, and attitude remains nominal.
Everything looking good. The fairing has been separating. Cygnus is now revealed in the inner stage at the back of the vehicle, separated before stage 2 ignition.
Attitude remains nominal.